This book is a compilation of the results of 4 years of research and studies into effective defect reduction methods conducted by the TZD Total Zero Defects study group with 21 leading companies in Japan. It introduces the results that have already been achieved by many companies in Japan. I would like to introduce some of the methods for dealing with defects caused by physical phenomena. This diagram shows a method used by Toyota and other companies to capture the actual product on-site and take measures when a product with a high risk of defect is discovered at the manufacturing site. The QTAT method was studied internationally at NUMMI in the 1980s. At the time, the quality of Japanese cars was superior to that of American cars, leading to Japan bashing, as shown in the figure. However, when American automakers used this method, the quality of their cars improved, and it contributed greatly to improving the US economy, which was in a recession at the time. Factual analysis is essential to analyze defects caused by physical phenomena found in automobiles in defect countermeasures. Therefore, this book uses questions of this type to guide you in improving your understanding. As anyone can see, if you want to know the condition of the trees up ahead, you can simply go to the place where the trees are planted and check the facts. The first thing to do when dealing with defects is to look at the actual product at the time of the defect and analyze the mechanism behind the defect based on the facts. However, as shown in the figure, there are people who take defect statistics and hold regular meetings to brainstorm measures without analyzing the causes of defects. This type of measure, which uses fact analysis, has been called a death diagnosis measure. This book introduced examples and problems of this in detail. This is the situation where the difference between the defect countermeasures using the brainstorming method at the TZD study group and the method using fact analysis shown in this book was confirmed. There are many analysis methods for physical phenomenon analysis, such as Y analysis, but no matter which method was used, there was always a difference between the top and bottom of this figure. The second chapter is about HE countermeasures. I will also introduce an example that I have written in the book. Why does human error occur? Research into this issue has already been conducted in such detail that cerebral physiologists have run out of room to continue, and many demonstration experiments have been carried out. Therefore, the TZD research group has been conducting research into how to effectively utilize this in the industrial world. As a result of various studies and demonstration tests, the TZD research group created this procedure, which is effective for use in the manufacturing industry to counter human error. In the 21st century, when various IT devices are available at low cost, measures including this Poka-yoke device are effective in areas where there is a high probability of human error and there are investment benefits to be had in human error countermeasures. This is the first step in the steps shown in the previous diagram. This book contains many inexpensive and effective Poka-yoke and application examples, so we hope that it will be of use to readers. Human error is a physical phenomenon that occurs during procedures. In this case, the mistake in the packed products was not discovered until the customer unpacked the package, so it was several days later. Therefore, even if the name of the packer was known, it would have been difficult to analyze and recreate the situation at that time. So, when the workplace was investigated, there was a worker with zero human error. When a video was taken, there was a difference in the procedures. Then, measures were taken to ensure that everyone followed the procedures of the person with zero human error, and since then, this problem has completely disappeared. This book introduces many concrete measures and examples of zero human error measures, including this type of measure that is difficult to investigate. Chapter 3 describes measures to eliminate defects that occur during the new product development stage. This case is an analysis of complaints that Mr. Nakamura conducted at a company that manufactures and sells AV products. The investigation revealed that 85% of the defects were at the design and development stage. Therefore, measures were taken in terms of design reviews to reduce the number to 0. However, when investigations were conducted into cases of defects and complaints in products developed by various companies, this figure of 85% was found to be almost the same, so the TZD research group pursued measures to reduce the number to 0. If measures against defects are not taken during the new product development stage, the product will fall victim to the devil's cycle shown in the figure and will fall into an environment where the problem repeats. The way out is the design review method, which is effective and hassle-free. So the TZD study group conducted research and tried to apply it to many of the companies that participated in the study group. The TZD research group investigated and studied design reviews that have been carried out by world-leading companies. For details, we will ask our readers to refer to the book we are introducing this time. The graph on the left side of this figure shows that as a result of utilizing the countermeasures introduced in Chapter 2 of this video, the number of connection errors in the copy machines that were being produced at the time was significantly reduced. However, the measures taken after defects were produced are problematic. Therefore, the people involved in the field participated in thoroughly taking countermeasures against defects in the next new product, and as a result, the number of defects was low at 5, as shown in the middle of the figure. But this was further improved to 3. Furthermore, further design reviews were carried out for the next model change. Then, a plan was devised to use the IT that controls the copy machine as a mistake-proofing measure. As a result of using this plan, this new product achieved 0 defects from the beginning of production. In Japanese industry, the DR countermeasures systematized by the TZD study group have been evaluated as extremely effective. This figure shows an example of this situation. When the method was applied to the development of a new audio equipment product, not only was the total man-hours required for development reduced by half compared to similar products, but the new product development period was also shortened by 1/3. This book also introduces other examples of CAE application. Thank you very much for watching the introduction to this Kindle book. The above explanation is the gist of this picture book. You can also get it at this URL. Amazon Prime members can watch it for free.